Hi everyone, my name is Yaron Glazer. I'm an independent researcher in the fields of mechanics and biomechanics, and I'm here today to introduce a new cyclic model of human gait.
An article by S.S. Wilson in the March 1973 issue of Scientific American famously argued that a man riding a bicycle is around 5 times more efficient than the same man walking unaided.
Subsequent research supports this claim, suggesting that human gait is far less efficient than predicted by the inverted pendulum model, the standard biomechanical model for human gait. Research over the past 20 years suggests that the main reason for this efficiency gap is the transition between steps. The body's falling mass must be redirected upwards and transferred laterally between legs with each step, and the energetic cost of this transfer increases exponentially with both step length and width. I've spent the past few years developing an alternative model of human gait in which the lower body functions like a wheel instead of a set of conjoined pendulums. This model avoids the costly transitions of the pendulum model and produces a cyclic gait. You can see it in action here. Motion under this new model involves two complementary sets of actions. First, the swing foot clenches and inverts for placement, while the swing leg rotates laterally back and in, as if to land the heel on the extended midline behind the stance foot. At the same time, the clenched and inverted stance foot pushes sideways against the ground with its outer edge, causing the entire foot to rotate inward from heel to toe. These coordinated movements around the ankle hub produce torque at the knee hub that is translated by way of a virtual axle to the pelvis, where it drives the swing hip in an arc around the midline to position the swing foot for the next step.
Unlike conventional gait models, where the feet act as levers pushing down and back into the ground to propel the body forward, this new model of gait reconceives the feet as dynamic, three-dimensional spirals that rotate inward around a central axis with every step.
Fully developed feet will roll back and forth over the extended midline, cycling beneath the body's center of mass to produce a biomechanical profile similar to that of a bicycle tire. Even feet developed under the standard model can be redeveloped as spirals, at least through midlife, using a targeted exercise that engages the counterspiral mechanism, the lower body's symmetry-based development engine. The mechanism is activated when the feet are rolled inward against each other at the body's midline, under controlled application of the body's weight, cycling through 3 specific movements that over time reposition the bones of the feet into their spiral structures and then stretch muscle and connective tissue over the resulting framework to wind the lower body. I was able to transition my own feet from the standard model to the spiral model over a 5-year period, starting at the age of 41. During that time, I experienced significant performance improvements along a number of metrics, though empirical validation of the results is still needed. I welcome suggestions for experiments to test the validity of the spiral model or my claims about its efficiency. More information can be found at www.counterspiral.com. Thanks for your time.